started, so please take it away.
Hey everyone. This is a long conference day, but you're at the end. So we're going to be talking about how to build an online scientific organization. I'm Niklas. I'm a physician and computational biologist by training and a founder of LabDAO. So at the outset for this talk, I just want to actually use this slot, the Graveyard slot, to do a bit of a recap of what is decentralized science, what did we actually learn. I think one of the key three core messages of decentralized science is the idea that we can build more accessible funding opportunities, and that this because we have on-chain wallets, so everybody can be sent funds and everybody can spend money in an extremely transparent way. We can have new forms of distribution and ownership, be that through hypercerts or IP NFTs, and we can experiment with new forms of accessible tools and data through platforms like LabDAO, IPFS, IPLD. Now, let's get to a bit of a personal story about why I'm here today and why I'm not in academia anymore. So this is a plot that shows the inventor net migration patterns across different countries. So on the y-axis you have the migration patterns of inventors, where an inventor is defined as someone who has been publishing a patent in the past. And then the x-axis you see different nations. And what you can see when you look at this is that the dots are the net position. So basically, are you a net exporter or a net importer? And there are actually just a couple of countries, the United States and Switzerland really, that are net importers of inventors, and all of the other countries are overall net exporters. And that is because human capital, just like financial capital, goes where it gets treated best. And inventors want to be in an environment where they have access to tools, access to funding, access to great colleagues that stimulate them and make them do their best work. So I was born over here in Germany, and then my parents took me to California as a child. We had to go back. I studied medicine in Germany, started doing science there. Was somewhat frustrated with the system, but didn't know any other alternative until I went back to the States for grad school and worked there for some time at the Broad Institute. I think my first grant that I ever got was an AWS grant, $10,000, just sent to a student, and they're able to do whatever they want. It was one of the most awesome experiences, so I don't know whether the AWS person is still in the room, but hopefully she, through some avenue, hears that. And then, however, because of a visa issue, I had to go back to Germany, and I was like, well, this kind of sucks, because all I need is a laptop and an internet connection, but now I get sent back and I lose all my access to a really stimulating scientific environment, and I'm back in Germany, where I felt like the community was actually not that supportive. There was not that much funding to do very translational research that comes out of computational biology. So at some point the question was, well, if more and more inventors are able to work completely online and in a digital realm, can't we build a place for inventors that's completely online? A scientific organization that's completely online, where you use tools on your computer, you have access to physical laboratories if you need so, and your IP is generated within an online community, and you're in full control of how it is used. And in essence, that's basically trying to build a group of people that can actually do decentralized science. But decentralized science itself is actually not that much of a new idea. So it really started already in 2010. When you look at this plot, you can see percentage of between city collaborations of all the patents that have been filed to the US Patent Office. And you can see that the proportion of patents where you have people from more than one city collaborating with each other has really consistently been increasing since 2010. Now, not only are more and more scientific projects collaborative and inventors work together across distances, but also I'm going to learn this at some point in this talk. These teams are actually more disruptive. So this is another study where they actually analyzed the patents that were filed by teams, and they looked at how disruptive are patents. And surely there was just a couple of weeks ago another paper in Nature that made the waves with basically inventiveness and disruptiveness in published papers and patents decreasing over time. In this particular study, they used an analogous method to measure the disruptive potential of a patent. And while in the past, in the 1980s, when you had an international or cross-city collaboration, the probability of you having a disruptive patent was actually lower than the average. Since, again, the 2010s, your odds are actually higher if you're a distributed team, if you bring in different influences and backgrounds. So we really should start with projects. Projects are the base currency of science. So it all starts with an idea. It all starts with a conversation at a conference where we say, oh, what if we combine X with Y? Or the time when you read a paper in the afternoon and you think about, well, with this new method, what if we did something different? So at LabDAO, we really went one step back and said, okay, how can we create a product that makes it very easy for a scientist, no matter their maturity and their traditional training framework, to share their idea and to be able to receive funding for it. So when you head to the LabDAO website, which is now updated and live, and you click on Create a Project, you will create, with your GitHub, a wallet. You don't need to stress about any of the crypto elements. It's just by using multi-party computation via Web3 auth, you have a wallet instantly, and you keep it secure with your GitHub account and a local key that's stored on your laptop and sent to you via email. Now with that wallet, you have suddenly access to all of the nice things that Web3 allows you, which is you can manage your own project funding, you can own project-related certificates, you can demonstrate achievements through Git POAPs, you can also access certain token-gated tools, and you can vote eventually on the organization's directions as well. So then you go and you create a project, and this is all IPFS and grants protocol compatible, so you can take this description of your project and make it visible on platforms such as the Gitcoin grants protocol, which is set to be released in a couple of months. And if you hit the QR codes, I have some buried throughout the presentations, you can test these tools yourself. So I think this has been actually one topic that's been a bit underreported at this conference. Is like, what is actually the future of scientific funding? How does it look like? And how do we actually create these bridges between the foundations, the investor DAOs, potential VCs, the existing large national funding agencies? And I think it goes all the way back to Alok's talk at the beginning of the conference. So this is one extremely popular mechanism in Web3 to fund projects that has been basically pioneered by Vitalik and Glenn Weil in 2019, which is called quadratic funding. The idea that if you have a verifiable way online to show that you are a real human, we can change the way that donations work. So usually if you would like a project, you would send money to it. But obviously if there is someone who has way more capital than you, they will have way more power in steering the direction of that project. However, what if we introduced a quadratic penalty where the big player, for example, a Wellcome Trust in the future, if we can convince them to adopt these technology, where the Wellcome Trust would say, okay, we're taking a step back. We're not picking winners here. We are a matching pool, and then other individual agents that are qualified, but also maybe just citizens, can fund projects that they really care about. And the citizens will actually, through their vote, govern how much funding the Wellcome Trust allocates to each of these individual projects, and thereby enabling a society in which also citizens can have a say directly which projects should get funded. This is already live on Gitcoin, and it's actually working pretty well for them. They're just piloting with UNICEF grants this quarter, and they have a couple other rounds coming. And I personally believe that this is something that if we talk to regulators, if we talk to the public funding agencies, we should bring this up as a prime example of how also public and private can work together, which is what I'm going to get to now. Because not only is quadratic funding super useful, but when you tie that up with certificates, be they hypercerts or IP NFTs, I think you have a really interesting match. So what if every science project had certificates owner that can steer the work of the project, and basically those certificate owners, they would earn that certificate when they would participate in this funding round. I think there's some really interesting second order effects. First, every scientific project would be directly registered. So if you think about these open science goals of pre-registration, that's baked in. Because the scientist wants money. Well, if you want money, you better register that thing on chain. And you also know all your stakeholders directly. If you want to eventually demonstrate that you support a scientific project, you show your certificates. If you want to show that you worked in a scientific project, you show your certificates. If that project turns out to spin out a biotech company and you ask yourself, well, how do we structure the cap table? Well, we better look at the certificates. So basically, just like carbon certificates and putting a price on carbon has a real potential to help us save this planet, I think creating certificates for just open source work in general has a real potential to get us out of this mess that we have between this world that runs on citations and the world that runs on the US dollar. So let's run through two potential scenarios for two different scientific projects that would follow this model where we marry quadratic funding and impact certificates. So project A is a project that is scanning the C. elegans brain and really trying to build a high-resolution atlas. A lot of people in society would agree that that project has high value, but you wouldn't be hard-pressed to find a venture firm that would underwrite that risk, because the time discounted value of that project is just too low, given all the uncertainty of how that information would translate into something tangible like a product. So probably would end up with a lot of people in the public over time just giving a couple bucks, and then the Wellcome Trust here in the gray bar would end up giving the bulk of the funding. Now, if that scientist has to eventually report to their shareholders, to the certificate holders, the Wellcome Trust here in gray would be the primary shareholder, as it should be, right? The science funding agency is the one that one should answer to if they end up being the funder of the science. So we have a lot of small transfers, a large relative match, and ownership is with the public and a large matching pool provider. Now let's take another project, Project B. Project B is a highly applied project. It's looking for, it's testing a new gene therapy for a monogenic disease. Before that thing sits out there for like 2 weeks, two venture firms just around the corner of this institute have already scoped it out, have placed massive bets, concentrated positions. There have been few large transfers. The Wellcome Trust just does a very small relative match based on these formula, and the ownership is with the high conviction funds, as it should be. You don't want to have a lot of debt weight on your cap table when you really want to turn it into a company. So I believe this is one potential formula how we as a community that are interested in decentralized science can address both people in the private markets and in the public sector about what is the utility of all of this that we're cooking up. It's not only the sharing of data, but it's also the accountability of projects, making them countable, creating certificates that measure actual value, and then giving the funders of these projects some form of utility on top of that. So we're at LabDAO helping scientists, especially young scientists, go that route. These certificates are still a bit nascent, so they haven't been rolled out yet, but definitely these teams have been participating in Gitcoin rounds and have been able to raise in aggregate about $40,000 for their respective computational projects. So one project I'm just going to highlight here is from Mike Pica, who is in industry actually, and has a passion for science and wanted to create a discourse graph, a knowledge graph for aging biology. And this is currently live. It's based on Obsidian, a discourse graph, which is a form of a knowledge graph where you separate different hypotheses and claims and evidence, and it's browsable by the public. And eventually the idea is if you create an on-chain instantiations of it through the tools that Martin and the team is working, you eventually can also reward contributors with certificates that have done that kind of work. Now projects and talking about what you want to do is just one part. But if the moment that you actually want to run some code, or you want to talk to someone who has expertise, or you want to run wet lab experiments, you have to sort of leave that community. It's not very useful to be in DeSci. So the second aspect that we arrived at relatively early was the idea that, okay, not only do you need to be able to talk about your project and raise some initial funding, but you also need to have access to tools to enable your science. So what we've been providing is notebook infrastructure, a place for your work. If you're a computation biologist and you're a member of the community, you can access this server today and you can start working on the stuff that you're interested in. But beyond that, we're also containerizing some applications that we believe to be extremely relevant for community-driven, especially translational science. So this is work done, for example, at Regina Basulai's lab at MIT, DiffDoc, that we've been containerizing and made sure that it runs properly, and we were very happy that we have the support from both the LabDAO team and the DeepCam community in making all these things work. And then when we go into like some use cases that we've been exploring, I'm just going to pull this one up that we did 2 weeks ago. It's now submitted, I think, first at bioRxiv and then eventually other venues as well. This is a compound that came out of a lab at Washington University in St. Louis, in Tim Peterson's lab. It's a compound called BioIO-011, and that compound was identified in a CRISPR screen. Nobody knew really, was it binding the proposed target and where exactly was it binding, and we used some of these new models that we've been putting together to at least generate a hypothesis that we now have to follow up on. Now, we don't want to stop with just dry lab. We want to go all the way, so we made sure that we're ready for wet lab, and I'm very happy that we can announce a partnership with Zero-matic and other Zero aggregators that allow us and all the members in the community to access also contract laboratories to do physical laboratory experiments based on their designs. Now, this has all been an effort from a loosely connected community, which I think is the most impressive piece of this all. So when we launched LabDAO, it was very clear that we wanted eventually just be this network of agents online and not a for-profit company. And it was extremely hard to convince people that this was something that should exist and they should support. And I'm extremely happy that this community came together. They're building all these pieces, and we were able to find people that also really want to make this exist in the world. So happy to announce that we raised an initial funding round, and we're going to be keeping this work. And this is also because of a lot of community engagement coming from all of you at DeSci London. So I think I'm going to stop with thank you, everybody that attended, and thank you. This was such a great conference.
We've got time for questions. So does anybody have any questions? Does anyone have a burning desire to have this box thrown at them and they haven't had it thrown at them yet? If so, raise your hand. Or just if you have a question you want to ask as well. Just raise your hand. Yes, over there.
I have a question about the wet labs. Does, like, let's say it's within a university, is there now a negotiation between IP rights and if you lose our stuff, and how does that,
So it depends on what your affiliation is as the one that's doing the work. So we make sure that in these relationships with a contract research organization, for example, you negotiate the IP terms. So some CROs want to have some equity or some future royalties from the work, but that is all now yours to decide, which is, I think, what's extremely important. I think, giving a university or someone who's providing infrastructure for you to do your work, giving that person or that institution some equity is not the worst thing in the world if you have the option to opt in or out. But I think a lot of us, especially the students, find themselves in situations where they just sort of apply to a grad school and nobody calls the tech transfer office and asks, well, if I come up with a startup while I'm in my PhD, how much equity are you going to take? Those questions are not getting asked, and these universities are not doing a really good job as giving us the deal terms of doing a PhD at their institute. So we want to turn this completely around. When you're with LabDAO, you control your equity. Eventually, maybe that we will introduce a tier where we want to also ask you to give us some for your project in token space, but you will know upfront, and then you will be able to negotiate with every other player that you want to involve in that project.
Very cool, thank you.
Thank you. Are there any more questions? No? Okay.